in Thread 22.40, some changes have been made to the MPC Advanced Ray Trace dialog, which now supports some new options that offer control over bringing back parent rays following either of the two GPU trace modes. So the MPC CPU trace is needed when working with sources that are not natively supported on the GPU, or doing analysis not yet supported on the GPU. So if I just start one of those traces now, so this is the MPC CPU trace. The rays are created on the CPU, which supports every source type within Thread. Those rays are then handed off to the GPU, which traces them in batches of launches. Each launch consists of a pre-launch step, a launch step, which is the actual trace of the ray, and a post-launch step. And we can see that the total time taken there is around 13.5 seconds. And if I take a look at the pre-launch, launch and post-launch times here, we can see that the post-launch occupies actually the most time of any of the three stages. So in this type of calculation, the post-launch brings back the parent ray set at the end of each launch. And we can calculate things. So we have a detector entity in this system, which is calculating our irradiance plot. But because we brought the ray set back into the CPU ray buffer, we can also run calculations that aren't natively supported on the GPU, things like the color image. Okay, so here's our color image of the rays in the CPU ray buffer that was returned to the array buffer following each launch. Now it's nice that we can do this, but if we don't need a color analysis, spending that 0.35 of a second bringing these rays back is actually something of an overhead that we could do without. And so that's why some new features have been added, some new options have been added into the ray trace dialog box. And where we are doing a CPU MPC trace, we can deselect now the post-launch step of bringing those rays back. So if I redo this trace without bringing the CPU parent rays back, then again, same process is followed in that the ray sets are created on the CPU, the rays trace in these launch batches. But now the post-launch steps drop from being around 0.35 of a second to being very, very small values indeed, and the total trace time drops to just over 9 seconds, which is about a 30% speed up, which is significant in longer traces of many, many more rays. So that's a great feature to have. Now if we think of MPC GPU ray trace option, in this option, it's arguably the more simple option to understand, in that simply everything happens on our GPU. The rays are created there, they are traced there, and the analysis is done there. No rays in this case come back to our CPU, in which case we can still calculate things like our irradiance. That's done natively on our GPU as part of our trace. But if we wanted then to run our color image, in this case, we wouldn't get 0 results because no rays have come back. In fact, actually, that's not what's happening here. In this case, what's happening is because there are no rays in the CPU buffer, actually, Thread knows there are no rays in the buffer and is rerunning our trace using our CPU, which is going to take a long time. So I'm going to cancel that and stop that trace. Okay, so we can't do that natively on the GPU. So that's where the new option comes into Thread MPC again, in that an option has been added onto the GPU trace side of things, that after the trace is complete, that we can choose to select that the parent rays do come back from our GPU trace. So in this case, if I choose this and press OK, the rays are created on our GPU, they are traced on our GPU, but there is now a post-launch step which brings those rays back to the CPU ray buffer. So this ray trace takes a little longer than the standard GPU trace that doesn't bring any rays back. But the advantage now is, again, as well as being able to calculate things that we can normally calculate on the GPU, such as the irradiance map, that we also have the option to calculate things that we couldn't normally calculate directly on the GPU, such as in this case, the color image. Okay, so these two options give us more flexibility in terms of controlling whether or not we bring these parent rays back. Should note two final points here is that both options have this asterisk as a prefix. The asterisk represents the fact that these options are document state settings. That means that the setting used is saved with the thread file, and in subsequent traces, even when not using the advanced trace, they'll still be used. So in this case, because we've turned off bringing parent rays back for the CPU, if I were to cancel this and just go ahead and rerun the MPC CPU trace, those parent rays will still not be brought back. Okay, so when we set these flags, we are essentially setting a document setting which is applied every single time and to every single trace, irrespective of where we start that trace. And the other point to just bear in mind is that these options do only apply to parent rays. So by parent rays, we mean that the ancestry level is 0, i.e. they haven't split. So any child split rays do not come back from the GPU under any circumstances. If you are relying on doing some trace where you do need the whole ray set to come back, then these options are best used with the Monte Carlo ray trace control, because in that mode there are no child rays and all rays are parent rays and therefore come back.